So we're here with ISORG.
Yeah.
So who are you?
I'm Laurent Chamet. I'm one of the founders of the company in charge of the business development.
So what are we looking at here? What is this?
That's the first image sensor on plastic. So we are the first company to develop image sensor on plastic.
Did you say image sensor?
Yeah.
So like a camera? Or?
It's like a camera, yes. What we are developing is large area image sensor with different market and application.
So are you able to recognize the Joconde, or how does it work?
Yes, so that's for this demo is the principle of scanning surface, where you just scan on all over the surface the image. One of the first application is for medical markets, where we are developing large area image sensor for X-ray equipment, where we can develop more cost-effective products or more robust products with the plastic substrate, so more robust to shock.
So how much more cost-effective compared to existing solutions? Or is it just different solutions?
No, it's a very significant cost reduction, at least 30% reducing the cost versus the traditional technologies.
And what are you showing here, for example? Is this a touchscreen?
So that's a new also proof of concept where we just integrate the technology behind the LCD. So the principle that you just push infrared light over the surface of display, that's the light is reflected by your hand and pushed through the display and detected by the optical sensor. We create just the 3D effect. We call it the post-tactile technology, just to create new effect with 3D interaction, typically for graphics and gaming.
So this is different from normal touch?
Yes, that's different for normal touch because it's compatible with touch.
You don't actually touch.
You don't touch it. You can touch if you want.
You can,
but
or you get close.
Yeah, but you can also interact without touching the surface.
How far can you be?
Typically about 2-3 centimeters, just to create interaction with graphics, typically for gaming.
So you just do quick gestures, and how about wearable? Does it go in there?
Wearable, so that's also something we are just starting to develop. That's typical, this kind of band that you can put inside the wrist. So it's flexible, like this. And that's we can use for different applications. Can be used for biometrics application or health monitoring. We just can monitor, for example, the blood in the hand, and you can have very accurate information, for example, on oximetry. So that's typical for biometrics or health monitoring.
So where would you put this exactly? It looks a little bit dark. Does it go in front of the screen or on the side of it, or where does it go?
So for this one, it's going to be inside the plastic, for example.
Inside the wristband?
The wristband, that's typical integration possibility. For the display, it will be backside of the display, so you don't care about transparency. So just behind the LCD stack, and that's the major benefit of the technology. You don't need to be transparent.
Because there is this distance that works.
Because the infrared light is going through the LCD, so it's as we are sensing the infrared light, we don't need to be in front of the display.
But are you losing some sensitivity because it goes through something?
Yes, so we need that to have a very sensitive device, exactly, to detect the minimum light quantity, yes.
So what are we looking at over here? What is this?
So that's the typical foil we are manufacturing in the pilot line. These are unit photodiode, okay? So each point is a pixel, is a photodiode, and typically you can use this, for example, for user interface products, where you can interact, you see, without touching the surface.
What is this number?
It's just to indicate that you are detecting position of finger all over the surface.
So right here in this product you have some of these there.
Exactly, yes.
How many of these do you have there?
It's typical about 12 sensor, yeah. 12 position, yes.
So this could be perfect for a smartwatch.
Yes, our typical application is for home appliances where you can interact with surface with breeze or water.
So it's not taking pictures, right? What is it doing?
Depends on the application. You can take pictures. For example, for this one can be the concept of mobile scanner. So just imagine that in the future you get just a surface able to scan typical barcode. So it can be used for barcode reading or tag code reading. So you can take a picture of a special code.
So how efficient is it at reading this barcode compared to a regular smartphone camera?
It's the concept is to have this, for example, embedded inside the equipment or inside the wearable equipment. So that's compared to camera, you don't need to have a special camera or device. It will be embedded inside the equipment.
So what's the weight? What's the power consumption? What's the price?
Very low power consumption, very low weight. We're talking, you see, about few grams. And the prices can be typical depending on market and product, but very cost effective because we are printing materials on surface.
So your material is on this?
No, this one is just an example of barcode. The product is this one. We are just making deposition of liquid material on top of the plastic.
All right, so just a little liquid material.
Yes.
So are you in you printed electronics?
Yes, that's exactly what we call it, the printed electronics, because we print materials, liquid materials on plastic. You call it organic electronics because we are using organic materials from the organic chemistry, or you can talk about large area electronics.
So is this only some prototypes? How about huge quantities? How soon?
We plan to have mass production units in 2 years in Limoges, center of France, and with first product, for example, for connected objects. So we are right now developing product for volume quantity within 1 or 2 years.
And you need some printers, some hardware to make it? You're not making those things, right?
Yeah, we buy equipment. We make some special partnership with equipment suppliers.
So right now it's just a prototyping R&D stage, right?
Right
and
now
mass production is
within
tuning.
2 years. Yeah.
Within 2 years.
Yes, with the mass production unit in Limoges. Yes.
So how big is it going to be? Are you the only ones doing this?
Yes, we are the only company developing optical sensor on plastic. There will be a large capacity manufacturing unit in Limoges.
So this is a little bit. It's funny because this is like, it looks like a display, so it could cover the display, or no, it could cover the area of the display.
Yes, it's behind the display. Yes.
So what's the future? Is it just going to be able to take pictures and stuff? Is it going to get better and better? What's happening?
No, the future is really to support emerging, let's say, mega trends for the electronics. So for medical segment, new sensor for medical equipment, wearable device, security, with biometrics, health monitoring, connected objects. So we are supporting all these mega trends of the electronics for medical segment, health control, security, and connected objects.
Robotics? No.
Robotics as well. Exactly.
Yeah.
Yes.
Wearable robotics and IoT stuff.
IoT, yeah, industrial IoT, yeah.
So basically, when you get close to something, it knows you're there or something, or?
For the market, we are just.
Or the humans interacting with
things. Yes, human interaction, so detection of the object, and optical sensor is very good because it's not intrusive.
So did you invent this?
It's not really invention. It's the vision supported by the founder of the company. Is a product vision, and we work a big research lab to develop the technology. So it's a mixed competence of technology, product design, and business development.